Hey there, it's Jamie again, and this is the third video for our Chapter 4 on descriptive data mining. Here, what we're using is we're going to calculate Euclidean distance between a variety of observations in order to assess what the distance is between clusters. So I have the same data set that I've been working with, but I've changed it a little bit. I've kept only the columns showing the standardized scores, and I've added another column here called cluster to illustrate what I'm doing. I've broken my data down into two clusters. Cluster 1 consists of observations number 3 and number 9. Cluster 2 consists of observations number 14 and number 16. And I'm wondering what the distance is between the clusters. So the first thing I have to do is measure the Euclidean distance between all points in the clusters. I don't need to measure the distance within a cluster, so I wouldn't have to say how far apart is 3 and 9, and I similarly don't have to ask how far apart is 14 and 16, but I do need to know how far apart 3 is from 14, how far apart 3 is from 16, how far apart 9 is from 14, and 9 is from 16. So I have to calculate 4 distances. And by breaking down my table so that it's much, much smaller and everything else is hidden, we can actually do it quite quickly. So here's how I set it up. I call this one diff between which observations, and I call this one the difference in variable 1 squared. This one is the difference in variable 2 squared. And this one is the difference in variable 3 squared, right? And here we see this is the difference in variable 1 squared age, this is the difference in variable 2 squared income, and this is the distance in variable 3 squared children. I'm going to keep extending out to the right. I'm then going to say sum of diffs, and then this one is going to be the Euclidean distance. Just because I'm a sucker for formatting, I'm going to merge these across to keep my spreadsheet balanced, otherwise I might twitch. Here we go. I'm going to center these. And so now I've got to come up with my differences. So I need to have the difference between 3 and 14. I need to get the difference between 3 and 16. Then I need to get the difference between 9 and 14 and 9 and 16. Right? And that gives me all pairs within my data set. So the difference between variable 1 squared for 3 and 14 is the difference between age for 3 and age for 14 squared. The difference for variable 2 squared is for observations 3 and 14 is the value for 3 minus the value for 14 squared, and that caret is shift 6 and then the 2. And then for the third variable, difference between 3 and 14, again squared. I want to center these, but I'm also going to add a couple of decimal places. Then I take my sum of the difference equals sum. Then I highlight the cells that I'm interested in adding up. And the sum of these differences is 10.13, and then I take the square root of that to get the Euclidean distance. Why did I change the direction here? Because it makes it a lot easier. So you saw how I did that, right? If I were going to be doing this in my own worksheet, I would actually take a different approach, and I'm going to illustrate that for you. Because once you've seen one go start to finish, what I'm going to do is I'm going to calculate the difference squared for the first observation for each of these observation pairs. So 3 and 14, 3 minus 14, close parentheses, shift 6, 2. For 3 and 16, it's equal to observation 3 minus observation 16, close parentheses, shift 6, 2. I'm going to do 9 and 14. And then I'm going to do 9 and 16. Okay, I did the first one, and here I've got all of my differences lined up directly below the variable that they correspond to. So I'm going to highlight and drag. Then I'm going to calculate sum once, and the square root of sum once, and then I'm going to drag down. And I have all my Euclidean distances here. All right, so it's quicker if you can get it set up right? And so whatever format your data comes in, think about how the data is structured and try to take advantage of Excel's functionality where it lets you drag. So we have these distances. Okay, so we're going to look at two types of distance measured. The first is single, and the second is complete. In a single linkage, the distance between two clusters is expressed as the distance between the closest pair in the clusters. So the closest pair here is the one with the smallest Euclidean distance, and that's 3 and 16. This is our closest pair. We would then say, if we were using single linkages, we would say that 3 and 16, which are 1.08 apart, that's their distance, is 1.08, that is now the distance between the clusters based on single linkage. So I'm going to call this the single linkage distance between clusters. For the complete linkage, a complete linkage tells us if we're using a complete linkage, we're measuring the distance between the clusters based on the pair of observations that's the farthest apart. So here, with a Euclidean distance of 3.25, 9 and 14 are our farthest apart pair. And so this is our complete linkage distance between clusters. So using that approach, you should be able to tell what is closest, or what pairs are closest, or if you're trying to add an observation to a cluster that's most similar to it, you would calculate the Euclidean distance and then decide based on the rules that you're given, whether it's a single linkage or a complete linkage. And that should be able to get you where you're going if that's what you need to do. All right, let me know if you have any questions. Happy calculating. My cat says hi.